Here's our last learning video on precipitation and water in the atmosphere. But don't worry, we're going to use all of this next week when we combine it with air pressure, wind, and severe weather. Here are a number of forms of precipitation. Many people think of precipitation as rain, but mist, rain, and drizzle, listed here and only really differentiated by their size, are the only types of precipitation that are liquid. Solid precipitation includes sleet, glaze, rime, snow, hail, and graupel. I'm going to talk about each of these, except graupel. Graupel is kind of unusual. It's a soft form of hail, but graupel does occur. I remember once when I was listening to the weather report in Pasadena that the weatherman said we had graupel reported that day. And it's kind of like hail, and you've probably experienced some hail in Pasadena. But let's look at each of these. I want to start by comparing the size of a typical raindrop to a cloud droplet. By now you've learned that clouds are made of very, very tiny little droplets of water, and I'm showing in this cartoon here the typical diameter of a raindrop, 2 millimeters, which is 2/10 of a centimeter. And then we have our large or small cloud droplets that are 1 to 2% the size of a raindrop. And then also in this picture, they have the condensation nuclei, which are 1% of the size of even the smallest cloud droplet. Remember that condensation nuclei are necessary for cloud formation. Water cannot condense from a gas to a liquid without something to condense upon. So clouds that we see that are visible water, right? They're not made of gas because we can see them, have little tiny condensation nuclei upon which all of the water droplets have condensed. In clouds, these little drops fall incredibly slow, and sometimes the winds up above us are enough to just keep them floating in the sky. There are two general ways that rain forms. One of them is called the ice crystal process. This is the case where the clouds are in below freezing temperatures, and instead of the clouds being made of little drops of liquid water, they're made of tiny ice crystals, snow essentially. And so if you have a cold cloud and it makes a bunch of snow, that snow falls, and if it eventually passes through warm air, it melts, and then we get rain. So that's one way to get rain. You start with ice crystals that get larger and larger with time, but eventually they melt and turn to rain. Otherwise, if they make it all the way down to the surface, we have snow. The other way we get rain is called the collision coalescence process, which is kind of a large fancy name for little raindrops become bigger raindrops. So in this case, we have a warm cloud where our cloud droplets are made of liquid, and they combine, as shown in this little cartoon, as they fall, and they get bigger and bigger and heavier, and then eventually they might actually split into some smaller ones, and all of those will do the same thing that this one did and collect other raindrops, and then they'll fall to the ground. So those are the two ways that rain can form. It can start as a solid and then melt, or it starts as a liquid and just gets larger and larger, heavier and heavier as it collides with other raindrops. So rain and drizzle, technically, are different only in the size of the drop. On the left here, I have a picture of rain, and in that case, this rain is at least 1/2 centimeter in diameter or larger. And then on the right, I have some drizzle, which is less than 1/2 centimeter, and it might even be significantly smaller. This also looks a bit like fog. Remember, fog is just a cloud at the ground level. Moving on to snow. Snow originates in clouds that are below the temperature of freezing water, and snow makes 6-sided ice crystals. And here's a picture of one. They say no two snowflakes are alike. And the 6-sided pattern is related to the mineral structure of ice, which has a hexagonal or 6-sided shape. When we talk about minerals, we'll talk about how ice is actually a mineral and it has a 6-sided shape. Then we can move on to something called sleet. Now, I don't know that I've ever experienced sleet in Southern California, but I used to live in Michigan, New York, and New Jersey, and we had plenty of sleet. Sleet is different than snow in that it starts out as rain, and as it falls from the clouds, it passes through a layer of very cold air, and so it freezes kind of on its way down. And it looks sort of like this. It almost looks like a combination of rain and snow. And it's really probably the most miserable type of precipitation there is. It feels like you're getting a Slurpee thrown on you, which is why an umbrella is good to have during sleet. Another interesting form of precipitation is freezing rain. Sometimes it's referred to as glaze. This occurs when supercooled raindrops freeze on contact with a surface. And so here in the upper right, we have some tree branches that are really, really coated with frozen rain or glaze. But these trees are in a temperate zone and they're accustomed to having this happen every winter to them. In the spring, the ice will thaw and they will bloom and have leaves and flowers. If this happened to the trees that are common in Southern California, they probably wouldn't survive the winter. This is an interesting picture down here. So this person's car and this person's car have been parked a little bit too long, I would say, in the frozen weather. And they are completely covered with glaze. This is the rear view mirror. This is the antenna. And these are not going to be thawed until the spring. So I guess those people don't really care too much about their car. Here's a nice park bench as well. And then you can see some cars in the background that clearly have either garages or they've taken care of their car every day. Another type of precipitation is called rime. And this forms on cold surface from a supercooled fog or cloud droplets. And so supercooled means the temperature of the fog is below freezing. But until it hits a surface, it remains a fog. And then it solidifies into this rime. It's very pretty, very feathery. Here are some more pictures of rime. Finally, I'm going to talk about hail. Now, the thing about hail that's different from all the other solid precipitations I just showed you is that hail is not a winter precipitation. The others are snow, sleet, freezing rain, rime. Those are all winter precipitations. Hail forms when there are thunderstorms. And thunderstorms form from cumulonimbus clouds. And these are most common in the spring. So hail is actually a springtime phenomenon. And what these are little balls of ice that grow inside a cumulonimbus cloud. And they get larger and larger and larger the more that they get carried into updrafts into the clouds. Once they finally get too heavy for that wind to carry them upwards, they eventually fall. Some hailstones have been reported to be the size of baseballs, which are shown right here. Obviously, if you got hit with one of those on your head, you would be in major medical trauma. Here's another picture of some hail. Here's a little cartoon showing the development of a cumulonimbus cloud or a thundercloud. So it starts with major updrafts. I talked before about why air rises, and this would be probably in front of a cold front where air is rising very quickly. And eventually it forms these huge cumulonimbus clouds, and the red arrows are showing warm air going up. The blue arrows are showing cool air going down because the air gets cooled once it gets high. And these drafts circulate in the clouds, and that is when the hail is forming. Eventually, when the hail, like I said, is too heavy for the wind to carry it upwards, it falls down, and it falls usually with the heavy rain, possibly lightning and thunder. Eventually, when the source of the rising air has gone, then the cloud produces a light rain, and hail is no longer being produced. Coming up is Unit 6, with wind, air pressure, and weather. We're going to take what we've learned about temperature and precipitation and tie everything together to make weather maps and predictions of the weather.